every week you will have a practical of 2 hours. This lab is having 1 credit, and for this you have term work of 25 marks. So for this lab you are not having any practical exam or not having any oral exam, but you have term work of 25 marks, for which you have to perform, you have to complete the lab, whatever assignments are assigned in the syllabus, to score this 25 marks. Now for this digital electronics lab, we have to prepare, student have to prepare a journal. The journal will consist of the laboratory assignments. In that journal, we are going to write down each and every assignment. The assignment will be in handwritten format, and each assignment will consist of the topics about assignment, like the title of assignments, objective, problem statement, outcomes, its hardware and software requirement, date of completion, assessment marks, and the sign. Okay, in theory part you are going to write down the concept, circuit diagram, pin configuration, and conclusion. Each student have to perform at least 12 experiments out of all the experiments given in the syllabus. The list of experiment in syllabus has been divided into 3 parts: group A, group B, and group C. So from group A you have to perform all assignments. From group B you have to perform any 5 experiments, and from group C you have to perform a single experiment. The continuous assessment of the lab assignments will be done based on the overall performance and the lab performance of student. The assessment will be done in the form of grades or marks. For assigning the grades and for giving the marks, we have certain parameters like timely completion, performance, innovation, efficiency, punctuality, and neatness. Due to this pandemic situation, we all are not able to attend the college, and we are not able to perform all the practicals in the college. That's why we are designing this lab in such a way that you can see these videos at home and you can practice the circuits by your own on your computers, on your laptops. Let us move on to the assignment list. So this list is divided into 3 parts. Group A is having 6 assignments, out of which you have to perform all. From group B you have to perform any 5 assignments, and from group C you have to perform any of the assignment. Now in today's lecture, in today's video, we are going to see the experiment number 1, that is to realize full adder and full subtractor with the help of basic gates. In lecture we have seen the basic gates. There are 3 basic gates: AND, OR, and NOT. You all are very aware about how the symbol of that particular gate is, what the truth table for it is. So now with the help of those basic gates, we are going to make, we are going to design, we are going to realize a full adder and a full subtractor. Now before directly moving on to the full adder and full subtractor, we should have some idea about what adder is, what subtractor is. So from the word itself, we can imagine that adder may be any circuit which performs the addition, or a subtractor is any circuit which can perform the subtraction. Yes, you are right. Adder is a digital circuit which is used for the addition of numbers, whereas subtractor is a circuit which is used for subtraction of 2 numbers. Before full adder, there is one concept of half adder, and before subtractor there is one more concept of half subtractor. So first we'll get idea about what is the half adder, what is the half subtractor, and then we'll move on to this full adder and full subtractor. So let us see what is meant by an half adder. So adder is a combinational arithmetic circuit which performs addition. In that two types, half adder and full adder. Now what half adder does? So half adder is a combinational arithmetic circuit that adds two numbers. Okay, half adder perform addition of two numbers and it produces two output again. First output is sum, which is denoted by S, and the another output is carry, which is denoted with C. Half adder is the simplest of all adder circuit. Half adder is a simple form of adder circuit, but it has major disadvantage. Now what that disadvantage is? Half adder can add only two single input bits. It can add a single bit number, two single bit number at a time. Let us consider A and B, and it has nothing to do with carry if there any inside the input. You will get better understanding of this line by seeing the example. So if the input to a half adder have carry, then it will be neglected and it adds only the A and B bits. That means the binary addition process does not complete, and that's why it is called as half adder. So students, half adder is a type of adder. It makes addition, but it can make addition of only two single bit number. If you have the number A and B, which is having multiple bits inside, and if any carry is generated at some point, that carry will not be considered. The carry will be neglected and it will just make the addition of bits. It will not consider the carry. See how? Suppose we are having these two numbers A and B. A is having two bits A0, A1. B is having two bits B0 and B1. Now we are performing the addition. Our data is in the form of binaries. So we start making addition or subtraction from the very last bit, from LSB. And then we gradually move on to the MSB. So on LSB I am having this A0 and B0. Suppose while making addition of A0 and B0, a carry is generated. C0 will be my carry. But in half adder circuit, this carry is completely neglected. They do not consider this carry. They just make addition of A and B, and that will be treated as S0. They will neglect this carry. Then they will move on to this A1 and B1 and make addition of it as S1. Carry will not be considered. See this block diagram. It is a 1-bit half adder circuit having two input A and B, first number and second number, and the output is generated as S for sum and C for carry. See, if in between this addition of A0 and B0 is generating C0 as carry, but in the block diagram itself there is no any input of carry. It will just make addition of the numbers. It will not consider the carry bit. This is the disadvantage of half adder, and to overcome disadvantage, full adder has been designed. Now we have input for this half adder. We can design output as we have the input. Then let us see the truth table, the K maps, and realize the half adder first, and then we'll see the full adder. See the truth table. The input were A and B. So we can consider, as we are having two input values, there will be four possible combinations of input: 0 0, 1 0, 0 1 and 1 1, and the output are S and carry. So if I add 0 0, my sum will be 0, carry also will be 0. If I am having A as 1 and B as 0, sum will be 1, no carry, so carry bit will be 0. For 0 1 sum will be 1 and carry will be 0. If I am having both the bits as 1, then my sum will be 0 and carry bit will be 1. From this truth table, you all are able to design the K-map. So we are having two output. So we will design two K-map for the first output S and for the another output, that is C. So input are A and B. B will be negative, positive. A will be negative, positive. 0 1 0 1. So in case of sum, I am getting 1 when A is 1 and B is 0. So where A is 1 and B is 0, I am placing this 1. Then the another one I am having is when A is 0 and B is 1. So A is 0 and B is 1. So to form grouping, we cannot form the diagonal group. We can either form horizontal group or vertical group. So we have to group a single one separately. So we will have two groups. For this A, the equation, the term will be A and B bar. And for this A, we are having the term as A bar B. So it will be A B bar plus A bar B, which is nothing but the XOR. So we can simplify it as S is equal to A XOR B. See now for this C, for this carry, again we will design the truth table. Carry is generated only when both the inputs are 1. So when A is 1 and B is 1, we have placed this 1. No any element, no any 1 is present in another cells to form group with this 1. So I have to encircle this 1 only. So for this 1, the term is A B. So C will be equal to AB. Now from these two equations, we will realize the half adder. So the first, for sum, we have the equation A XOR B. So we'll require one XOR, and for carry it was A and B. So we'll require one AND gate. So for sum, we will draw a XOR gate and input to this XOR will be A and B. Whereas in case of C, we have the term as A and B. So A, this is A and this is B, input to this AND gate. Okay, now we'll move on to the full adder. We'll see what is full adder and its description. Full adder is a combinational circuit. It is a adder which adds 3 inputs and produces 2 outputs. In half adder, we are having just 2 input, a single bit A number and single bit B number. It doesn't consider carry. Okay, so to overcome that disadvantage, we can make use of full adder. The full adder has been designed, which has a third input also, which is carry in input. See, the first 2 inputs are A and B and the third input is the C in, that is carry in. The output generated from full adder are the 2 output, C out, output carry, and the normal output, which is designated as S, which is nothing but the sum. See, this is the full adder circuit. It has 3 input A, B and the carry in, and the circuit generates 2 output, sum and the C out. There in case of half adder, we just have 2 input A and B, and we have generated the 2 outputs, sum and the carry. Here the in between carry generated is also considered as C in input, and it generates the 2 output, sum and C out. So the truth table will be have 3 input A, B and C in, and the output will be sum and the carry out, C out. So in the first case, if you have all 3 inputs are 0, there will be sum also 0 and carry also 0. If you have A is equal to 0, B is equal to 0 and carry inside carry in is 1, then sum will be 1, carry will be 0. If you have numbers 0 1 0, sum is 1, carry will be 0. If you have 0 1 1, sum is 0, 1 plus 1 0, and carry will be 1. If you have 1 0 0, sum is 1, carry is 0. If you have 1 0 1 1 plus this 1, sum is 0, carry is 1. For 1 1 0, sum is 0, carry is 1. And in case of triple 1, A is equal to 1, B is equal to 1, and C is equal to 1, the sum will be 1. 1 plus 1 0, 0 plus 1 1, and the carry is 1. So this is how you have to design the truth table. From this truth table we will design two K-map. We will draw two K-map, one for this sum and one for this C out. So for sum, again the input are 3, A, B and C in. So this is A, B and C in. For A will be positive and negative, 1 0. And for BC we will have 4 possible combination, 0 0 0 1 1 1 1 0. Instead of writing these terms like this, you can place the binary digits also, 0 0 0 1 1 1 1 0, and on this side 0 and 1. So we are having sum when we have 0 0 1. See 0 0 1, here we are having 1. When you are having 0 1 0 0 1 0, this one, and then 1 0 0 1 0, and this A bar means 0. So here again you have to place 1. And the last one, when you have all three variables positive, A, B and C in. See A, B and C in. Here you have to place the 1. So we having these 4 ones in the truth table. Now we cannot combine all these 4 ones in one group. Also we cannot combine them in a group of 2. So we have to circle them single one. And if you form the equation from this, then see for this one, the term will be A bar, B bar, C in. So A bar, B bar, C in. Then for this term, for this one, you will have A bar, B and C in bar. So A bar, B and C in bar. Plus for this one, you have A, B, C in. So A, B, C in. And for this last one, you have A, B bar, C in bar. So A, B bar, C in bar. Now you can simplify this equation. You can minimize this equation, that from these two terms, this A bar can be taken as common, and inside we'll have B bar C in plus B C in bar can be reduced as the XOR. Here also you can take A common, inside you have B C in plus B bar C in bar, nothing but the XOR. So you have the equation now as A bar in bracket B XOR C in plus A in bracket B XOR C in, which can also then written as A XOR B XOR C in. So that's why for sum the equation is A XOR B XOR C in. Now see for C out, I have placed the ones. Here you have here again there are 4 ones, but all the 4 ones cannot combine together, merge together in one group. So what you can do is you can form this vertical group, and you can form this horizontal group and this horizontal group. Okay, and for each group then you have to write down the term. Okay, so for this vertical one, this vertical one are having, this vertical group is having 2 ones, this one and this one. This one belongs to this row and this one belong to this row. So A and a bar. 0 and 1 will get cancelled, and we'll see only this column numbers which are having b and c in. So for this vertical group the term will be b c in. For this horizontal one we will have this a, and from this b bar c in and b c in, b bar and b will get cancelled and c in will be there, so it is a c in. And for this one we will have a b c in and b c in bar, so c in and c in bar will get cancelled, you will have the term as ab. So for c out you have ab plus b c in plus a c in. Here for sum will require two XOR gates. Here will require OR gates and AND gates. See the realization. For sum, the equation was A XOR B XOR C in. So these three inputs are given to this XOR gate to get the sum as output. For C out, the equation was AB, so this A and B forms an AND. Then we are having B C in, so this AND. Then we are having A C in, so this and all these three terms are ORed together to get the C out. So this is how the full adder is going to realize. Now we will see the subtractor. So first comes the half subtractor. It is a combinational logic circuit which is used for subtracting two single bit numbers. It contains two input A and B, and it will generate two output, difference and borrow. Difference is the subtraction value and borrow if any have been taken. So for this single bit two numbers A and B, we have the possible combinations where 0 0 0 1 1 0 and 1 1. In difference, 0 minus 0, difference will be 0. If you have 0 minus 1, then difference between 0 and 1 is of 1. For 1 0, difference is 1, and for 1 1, difference is again 0. Out of this all four conditions, borrow will be generated only in second case 0 1, because we cannot subtract 1 from 0, so there I have to borrow 1. So borrow will be generated in that case only. In another three cases there is no need of borrow. So from this truth table I have designed the K map for difference D and for borrow B. So two inputs are there, A and B, 0 1 0 1. Difference is 1 when you have A is 0 and B is 1, so it will be A bar B. A bar B is 1, and another one is when A B bar, so A B bar is 1. Cannot form the vertical group. The equation will be A B bar plus A bar B, which is nothing but A XOR B. And for borrow, we are having 1 only in one case where A is 0 and B is 1, that is A bar B. So for A bar B, for this A bar B, we have placed 1, and it is not having any other companion one, so we have to group it as a single, and its term will be A bar B. So A bar B. We'll need one XOR gate for difference and AND gate for this borrow. See the realization. For difference, we have used this XOR who has input A and B, and for carry we are having A bar B. So this is a NOT gate is used for A bar. So this is A bar and this is B. So difference is A XOR B and carry is A bar B. This is how the half subtractor is going to work. Next comes the full subtractor. It is a combinational circuit which performs subtraction of 2 bits. It performs subtraction of any 2 bits, but the combinational circuit has 3 input. A is my first number, B is my second number, and B in. If any borrow has been taken in previous bits, then that is B in. It generates 2 output. D stands for difference and B out, which is borrow. So this circuit has 3 input A, B, B in and 2 outputs D and B out. The 3 inputs A, B and B in denotes this A is minuend from which we are going to subtract a number. Then B is a subtrahend, the number which I am going to subtract from the A, and the previous borrow, that is B in. The 2 output D and B out, this D and B out represents the difference D, and output borrow is B out. Let us see the truth table and the K-maps. So this is how the truth table will look like. The 3 inputs were there A, B and B in. According to this, you have to check and write down this difference and B out values. Now from this truth table, we will design K map, one for D and one for B out. I have taken 3 input A, B, B in, 4 possible combinations, and here 2 possible combinations. According to this one, in particular cell I have placed the ones, and if you joined all these terms and minimize the equation, you will get the simplified form for this difference, as it will be equal to A XOR B XOR B in. For B out, again we have to design this table. Here we will see we are forming these 3 groups. In every group we are combined 2 ones together. We cannot combine all these 4 ones together, so what we did, we have make 3 groups and each group have 2 ones. So for this first horizontal group, we will have the equation A bar B in. So A bar B in. For another horizontal, we have A bar and B. So A bar B. And for this vertical group, we will have the term B B in. So B B in. In these 2 terms, we are having the similarity. The first was A bar B in and the second was B B in, out of which we can take common this B in, and the simplified form will be A bar B plus A bar plus B B in. Let us check the realized circuit. So for difference, we are having the equation like A XOR B XOR B in. So this XOR gate has this 3 input A, B and B in. For B out, for borrow, we have the equation, the first AND of A bar and B. So this is A bar B. The second AND of A bar B in, so this is A bar B in, and the third AND of B and B in, and all these 3 ANDs are combined together with this OR gate to get B out as output. So everything we have seen from the half adder to this full subtractor is the theory part. It is the paperwork which you have to write down inside your journals, inside your assignment. Now we will see the actual implementation of how we are going to design, realize this circuit on the kit. So apparatus you're going to need to perform this experiment is we have designed the circuits using AND gate, XOR gate, NOT gate, OR gate. So for each and every gate will need IC. So for AND gate will require 7408. For XOR we will need 7486. For NOT gate will require 7404, and for OR gate will need this 7432 IC. We are going to place all this IC on a trainer kit, which is called as a IC trainer kit. And to make the connection, we have to make use of this patch cords. So these are the things we'll need to perform the experiment. Now we will see how we are going to perform the practical. So in last slide we have checked, we have learned that what apparatus we are going to use to design the circuit. So in that we have seen that we are going to make use of ICs, we are going to make use of IC trainer kit, we are going to make use of patch cords. So now the question will arise that what this ICs looks like, how the trainer kit looks like, how the patch cords are, and how we are going to use all these equipments to design the circuit. So we first see these ICs, then we'll see the patch cords, how they looks like, and then we'll see this trainer kit and how to mount ICs and how to use patch cords on those trainer kit. So IC stand for integrated circuit. It is something like this chip. Okay, this thing is called as, this chip is called as IC. Now the name is not given every time on this IC that it is a AND gate IC, it is a NOT gate IC. You have to remember the code, you have to remember the number assigned to each IC. Like here the number is given 7404. So see, 7404. So that this is the IC for NOT gate. So you have to remember this specification for each gate, that the IC number related to each gate you have to remember. Now it is 1 2 3 4 5 6 7. On this side it has 7 pin and on another side it has 7 pin. So this is called as a 14 pin IC. You have to remember the IC number. The IC number will be printed over this black surface. Now how you are going to place this IC? So IC has this knob. So this knob always should be in upward direction, like you have to put the IC, like you have to mount the IC. This knob always should be in upward direction. Okay, so this is IC. Now when we will place those IC on the trainer kit, when we will mount those IC on the trainer kit, what we are doing, how we are building the circuit, we are giving input to the gate. So the gates we are implementing with the help of ICs. So we have to give first input to the IC and we have to generate the output and we have to connect it to the output side. So to make this connection, give input to IC, generate output from IC, for all this connection we have to make use of this patch cords. See, it is having two ends. It is having the knobs on two ends, for here also and for here also. So one end I will place to the pin of IC and other end I will put either into the input part or to the output part according to the connections we are going to make. Now where we are going to place these ICs and these patch cords is on this trainer kit. So this is your trainer kit where you are going to place the ICs and the cables, the patch cords. So these holes you all are able to see. So these are all to mount the cables, and this 1 2 3 4 5, these 5 beds are to mount the ICs. In this round holes you are going to place the cables, and on these beds you are going to place the ICs. See, this beds are having handle on this side, a small handle. So whenever you are going to place the IC, first you have to open that handle, you have to move that handle in the upward direction, and after that you are going to place IC on this dashed structure. Once you place the IC, you have to close that handle so that IC will be placed firmly, it will not move after them. Okay, and as I have said that you have to place IC in a such a way that the knob should be in upward direction. So this knob should be towards this handle. In this direction you have to place the IC. How you are going to place? You have to open this handle, place the IC and close the handle so that IC will be firmly mount over there. Okay, now here this red lights are given, LEDs are given, and next to that these holes are given. So these are the digital output. When you have to give any output from a particular IC, then you have to make connection from any pin according to the data sheet, any pin, and that you have to give output on this output side. If you want to take input, then that input should be taken from this input section. This is a digital input. In output you have 1 to 10 pins. Here also in input you have 1 to 10 pins, and these holes are to make connection as per the data sheet of that particular IC. Now for making connection, you always have to give ground and VCC for each IC. So this is for the ground. See, for each IC the ground is given, and for each IC the VCC is also given. Okay. If in the next practical we will see where we have the experiments to operate on pulse, there we have to give the pulse manually. To give that pulse, see, this pulsar is also given here. Now whenever you will give input, if the input is in positive format, in positive value, the LED will glow. If the output is in a negative format, the LED will not glow. Same in case of this output. When a positive output is there, LED will glow, otherwise it is off. So if you want to show the output, to see the output in the form of this glowing and non-glowing LEDs, you should attach cable from ICs to this output. And if you want to see the output in the form of numbers like 0, 1, 2, 3, 4 alike, then, or if you want to see the values or numbers in the form of zeros and ones, then you can connect the output lines from the IC or from the input to this 7-segment display. This is the 7-segment display. If you have two numbers in your result, then first and second, see, A1, B1, like all, you can see the output in the form of numbers, in the form of digits in this 7-segment display. Okay, and when you are making the circuit, when you are joining the cables or when you are placing the ICs, the power should be turned off. Okay, power should be turned off, and once you are done with all connections and placing the IC, then you have to power on, and you have to check, you have to give the input and you have to check whether it is generating the correct output or not. Before starting the practical, when you attach this kit to the power supply, you first have to put the power on, and you first have to check this input pins, that whether they are glowing or not. You have to check this, whether these LEDs are glowing or not. This is why, to check whether this kit is working properly or not. Okay, but when you are doing the implementation, when we are actually placing the cables and ICs, that time you have to shut down the power. That time this power button should be off, and when you are done with this circuit, you want to check the circuit that whether it is generating the output properly or not. That time you can put this power on you, and you can check the circuits accordingly. Now Due to this COVID situation, we all are not able to come to college and to perform the practicals using all these ICs, this patch cords and this trainer kit. So I'm going to show you one simulator, one simulation tool which looks like this trainer kit, this IC trainer kit. It have all the functionalities, all the pins given on this trainer kit. So you can install, you can download and install that tool on your systems, on your laptops too, and you can practice all these experiments, all these practicals at home. So let us see that tool. So the tool for simulation of digital circuit or our lab practicals, I have searched one tool that you can use this tool at your home end too. So the name of that tool is Deld Sim is the name of tool. Search it over Google. The very first link is of that only. So click on that Deld Sim virtual trainer kit. Once you click on that link, it will open, it will show you the screen something like this. Now on this screen you have to click on this trainer kit, virtual trainer kit. Now see, uh, don't this look like the IC trainer kit which we have seen earlier? See, on that trainer kit also we have this IC bases. Here also we have the IC bases. There we have seen the output section where our output is going to be visible, and these are the input from which I am going to give the input to the IC. Now it is this high and low are to generate the pulse. Now in next practicals, when we need this pulse, then we can generate pulse from these buttons. This is the button for ground connection. This is for the VCC connection. And if you want to increase the voltage value, or if you want to minimize the voltage value, then you can select it from this particular buttons. Now if you want to display the output in the form of LEDs, then you can use this output section, but in some practicals we need to display the output in the form of 7-segment display. So in that case you can make connection to this 7-segment display. To power on the system, this is the power button, and again to power off, the same button we are going to use. This each IC is of 20 pin. So if your IC is of 14 pin, also you can make use of, you can place your ICs here, and you can perform the working. And the functions it provides, like if you want to add any IC, you have to click on this add IC. If you want to remove IC, then click on the remove IC. If you want to remove any cabling connection, then you have to click on this remove connection. And one more specification it has, that you don't need to keep your data sheet along with you. On this tool you have a data sheet too. Okay, so if you want to now we'll do a simple circuit of AND gate. So we have to use the IC from here. See, if I will click on add IC button, it will prompt me that click or tap on the IC base in which IC should be mounted. So on which base you want to mount your IC, that base you have to select. So if I have selected this one, okay, I have selected this one, then it will ask me that which IC you want to use, which IC you want to place on that. So see, NAND, NOR, inverting means not gate IC, and gate IC. the list of IC comes here when you click on add IC, and you have to select the one which you needs as per your need of experiment. So first I will take a and get IC which is 7408 IC. So I will click on this and I will click on add IC button. So see that IC get placed over here. Now I want to see the data sheet that how I should make connection for this IC. So I will click on this show data sheet button, and we are using this 7408 IC. So I will click here and I will click on show data sheet. It will give me the description of data sheet. So this IC consists of 4 independent gates, and each gate performs the AND operation. So the first pin is input, 1 is A1 input, B1 is a second input, and Y1 is on the third pin. I have my output. Again 4 is input, 5 is input, 6 is my output. 7 pin is ground pin, 14 is VCC pin. Okay. Again 9 and 10 are input, 8 is output, 12 and 13 are input, and 11 is output. So this is the data sheet, and this truth table, you know well that AND gives you output in high only when both the input are high. If both are low or any one is low, it is not going to give you the output high. AND will give you the output high 1 only when both the input are high, both the input are 1. So accordingly we'll make connection now. First pin will give as input, second as input, and third we will give as output. So let us move on to the trainer kit. Now here the first pin, this is the first pin. I will give this first pin to the input. So this is the input. So this is my first input. Second pin was again the input as per the data sheet. So this second pin I will give as input again, and third was my output. So I will connect this third line as output. Okay, this is the output line. And before starting with this actual connection, what you have to do is you have to first connect the ground and VCC pin. So see, ground was given with the 7th pin and VCC was given with the 14th pin. So this 7 pin will be given to the ground, and 14. So you are not going to calculate it with this 14 because it is 20 pin IC, but your pin is of 14 pin IC. So this is 7, then 8, 9, 10, 11, 12, 13 and 14. So this is your 14 pin which you will connect to this VCC. Okay, so we have made the connection. Now we will see the output, whether it is generating the proper or not. So when you will get this LED as glowing, when both 0 and 1, both input will be high, both will be 1, both will be positive, then only this LED is going to glow. So we will put on this power now. Okay, so we have powered on. See, this is the VCC connection. So now in first case we have both input as 0, both are low, so output is low. If I will turn on this, okay, now it is 0, 1, then output is 0. Okay, then I will turn off this and I will turn on this. Now also the output is 0. Now I will put on both the input. See, 1 and 1, and you are getting output as 1. This is AND connection. Both input are 0, output will be 0. Any one input is 0, output will be 0. Both input should be 1, then only output is going to be 1. Now if you want to remove any connection from this trainer kit, then you have to click on this remove connection. See, it will give you the error that sorry, you cannot make or remove connection when the circuit is on. So we have to power off the circuit first, and then we will remove connection. So click on remove connection and the connection you want to remove, and then click on remove connection and the lines. So likewise you will remove all the connections which you have made. Okay, so now we have removed all the connection, and now I will remove the IC using this remove IC. So now I will show you one more simple working of one circuit. So we will see the how NOT gate works. So click on add IC, click on the bed. 7404 is the NOT IC. Select the IC, click on add IC. The IC has been played. If you want to check the data sheet, then show data sheet. 7404, it's data sheet. See, if input is low, output will be high. If input is high, output will be low. Okay, so first pin is input, second is output, third is input, fourth is output, fifth is input, sixth is output, 7 should be to ground, 14 should be to VCC. So let us start now the NOT gate. So I have placed the IC. Now we will make the connections. So 7 should be to ground, this should be to VCC, VCC. First is the input, so here comes the input, and second immediate is the output. So this is output. Now let us check whether it is going to give me the correct output. Turn on the power. So now see, input is 1, so it is showing me output as 0. If I will turn on this, see, output is 1. So whenever you are turning it on, means it is 1, so output will be 0. If I will turn it off, means 0, so it will give me output as 1 as LED is glowing. So this is how you are going to implement the circuit. You are going to try the circuit using this DELT SIM simulator at home. So now finally we will proceed to implementation of our full adder and full subtractor. I will show you their circuit, their implementation on this same simulator, and you try them at home. So now we will implement the full adder. So for full adder we need this 3 input A, B and C in. For this 3, to get some output we need XOR gate, and for carry we need 3 AND gates and 1 OR gate. So we'll require one XOR, that is 7486, and that is 7408, and OR, that is 7432. So I have placed 7486 for XOR, 7408 for and 7432 for OR gate. Okay, and at the same time I have made their ground connection 7 pin to ground, and their VCC connection the 20th means the 14th pin to VCC. Now we will make their connections. I have also opened the data sheet for OR gate, AND gate, and the XOR gate. So whenever we will need those, we will also make use of those data sheets. Now we will start giving input. So for first XOR, we are having A, B, and C as input. So this first pin I will connect to 0 input. The second pin I will connect to this first input, and output of this first and second is this uh, 3 and 4, and the third input will be from this 5 to this 2. So these are the XOR 3 input 0, 1 and this 2. And now output of XOR means this 6. This 6 we will connect to this 1, that sum output. So A, 1, 2 and this 5 are the input of XOR. 6 is the output which we have connected to this one, so that we can sum the sum out. We can see the sum output over here in the output part. So we have done with sum. Now for carry, we have first AND gate of A and B. So this first will be connected to this one pin A, and this second, which is B, will be connected to this second pin. So first and second are connected to input A and B. Now the second AND gate is of B and C in. So this is B. This B will be connected to 4, this 4, and this C in will be connected to 5, this 5, and the last AND gate is of A and C in. So this A I will connect to pin 19, and C in I will connect to 18. Now this AND gate and this AND gate are ORed together. So this 3 output of AB will be connected to this OR gate, and similar to this 4 and 5, second output 6, this 6 will be connected to this 2, and third one, this 19 and 80, again AND gate, its output is connected to this 5, and similar to it, this is AB and BC, and we have connected all this AND to this OR gate, and now the output of OR, this 6, which is nothing but carry, will now then connect to this output 0 pin. Okay, so we have made all the connection, and now we will see the truth table, and we'll check whether it is giving us the correct answers or not. So this is the truth table. So the truth table have all the first three values are 0, and output means sum is 0 and the carry is also 0. See, all three inputs are 0 and output is also 0. Sum is 0 and carry is 0. Turn on the power first and then check the output. See, now all the three inputs are 0, so output will be 0. Now if we'll check another combination, we will see this a and b we will give as 0 and we will give c in as 1. So we'll check whether it is showing the sum as 1. So this is a, this is b and this is c in. I will turn on and see it is showing the sum as 1. uh, and now we will check one for sum and carry 2. So in this last case, we'll see this one where A, B, and C all values are 3 are 1. Then sum should be 1 and carry also should be generated as 1. So I will put on all the values. See, now the output is sum is also 1 and carry is also 1, because why? All are 1. So 0 plus 1, sorry, 1 plus 1 is 0 and carry 1. So carry bit will be 1. And for this two, again 0 plus 1 means sum is 1. So sum is also 1 and carry is also 1. We'll try one more combination. Suppose we will try one where carry is 1. So we will try 1, 0 and 1. So A is 1, B is 0 and this is C in is 1. In this case 1 plus 1 sum will be 0 and carry will be generated. So see, we are getting it, sum is 0 and carry is generated. In a similar way, we have to make a circuit for the full subtractor. We will see it uh, in the next video. In next very next video, we will see that this is for the full adder. So now we will see the full subtractor. For a full subtractor, what we need? We need those equation for full subtractor are difference is equal to a xor b in, and for borrow it was a bar b plus a bar b in plus b in. So as per the realization, for difference I will need xor gate. The input will be a, b and b in, and for borrow we'll need and gate, or gate, and not gate for inversion. So we will implement this full subtractor now. So we will in total need 4 ICs, uh, that is XOR, and OR, and NOT gate. Okay. So we will take ICs. The first IC I will take 7486 XOR IC. This is 7486. Then second we will take NOT gate, NOT IC 7404. Then third we will take AND IC 7408, AND IC, and the next last IC will require, that is OR IC. So for OR we will take 7432. So this is 7432 IC. So we have taken all 4 ICs here. Now for every IC we have to make the ground and VCC connection. Please look after that power is off when you are making the connections. So ground will be 7. So we have grounded all ICs and now we have to give them supply VCC. So now we have done with the ground and VCC for every pin, and now we'll move towards the actual connection of a circuit. So for difference we'll need XOR of A, B and B in. So we will give A to the 0, B to the 1. Let us see. So the first input A, this first pin of XOR, I will connect to 0, and B, second pin, I will connect to 1, and now the third one, that B in is remaining, borrow in is remaining. Now we'll see for that pin. The output of this 1 and 2, whatever output it will be generated, that output is going to be inside this pin number 4, and the next B in, and this fifth pin is our B in from 5 to this 2, and the output of our XOR gate, A XOR B XOR B in XOR, that is 6. This 6 we will connect to output, which gives us the difference. It will gives the difference. So we will connect this sixth pin to output to see the difference. Now we will move for the B out. So for B out we'll need first AND gate. See this, this is having B and B in, so we will AND it together. So this is B, and this second input to AND gate is this is B, and this is B in. So sorry, I was making connection on 7404 IC, which is not IC. We have to make that B and B in connection on this 7408, that is AND IC, because B and B in are ANDed together. So we will connect this B to first pin to B, and this second pin to B in, this second pin to this B in. Yes, the output of this AND gate, now this 3 we are going to give it to the OR gate as input. So this is input to OR gate, that is to 7432 IC. Now next AND gate we are having this A bar and B, so we have to invert A, and for that inversion we will take this A, and we will connect it to the NOT gate, and the output of this NOT gate we will connect to this NOT gate output. this is our input to the AND gate, this 4. So we will connect it here. So A naught we have connected to this AND gate. Now for B in, this B in is the second input for AND gate. So this B in will be connected to this 5. Yes, this is the 5, and the output of this 6, output of this AND gate is going to be connected to the OR gate. So this output 6 will be there to this input 2 of 743. And for the last AND, the A bar, A naught is input to AND gate, this AND gate, and B2 input of this AND gate. And now the output, and now this output, this 17 will be connected to this 5. This is to the 5, and this AND gets this AND gates, and these 3 AND gates are ORed together here to get B out. So to get this output, that output, to convert those all 3 AND gates to the OR, we have to connect this pin number 3 to this pin number 4, this 3 to 4, and so we have connected this all 3 AND gates to the OR, and all 3 AND gates we are connected to this OR gate, and now this output of OR we will give to this here for borrow. So this 6 we will connect to borrow. So this is how we have implemented the full subtractor using basic gates. We have 3 input A, B, and B in, and the output are difference and borrow. So now we will turn on the power, and we will verify the truth table. So in very first case, when all 3 input are 0, both difference and B out are 0. So see, all inputs are 0, and output are also 0 in this case. Now suppose we will give borrow as 1, then difference will be 1, and borrow is also 1. Let us check. So I will put on this B in input. See, difference and borrow all are positive, both are 1. Now I will check where only borrow will be generated. So 0, 1, 1. So in case of 0, 1, 1, see, only borrow they are showing. No difference is there. In case of 0, 1, sorry, in case of 0, 1, no, what we have given as input, we have given 0, 1, 1. 0, 1, 1. So D is 0, and borrow is there. Yes. Now we will see this 1, 1, 0. Okay, so 1 A minus B, 1 minus 1 will be 0, and there is no borrow. So we will check it, this 1, 1, 0 now. So 1, 1, and 0. See, no borrow and no difference is there. So this is how the full subtractor works. I hope you all must understand this working of half adder, half subtractor, full adder, and full subtractor. For today, we will stop here. In next practical, we will see the experiment number 2. Try to practice this experiment at home. Download this DelSim simulator and try this practical. If you have any doubt, you can contact me anytime. Thank you.